them? Or?
Stage 4 and stage 4 lung, and somehow they can't find any, like, you have new deep bodies, you got
So the last I really had heard of it was that it was a remission, everything was going good, and then life happened, and then it was just like, yeah, right. So, like,
Did you want the keyboard to advance? Okay. Put it at the end over here. All right, well, thank you all for coming. We'll go ahead and get started now. I think we're still waiting on a couple more people, but we'll go ahead and get started. First of all, I want to thank the steering committee for helping me get this set up, and then Nick and Jacob for presenting today, and thank all the cultivators for coming. This is going to be a great presentation to give us some really in-depth insights on some of the assessments that were done, you know, just some things you can do to improve your energy efficiency at your cultivation and just, you know, work more efficiently and, you know, save some money too. So I really appreciate everybody that came today and brought this together. But with that, I'm going to turn it over to Nick Collins to start off the presentation. Thank you. Oh, yes.
All right. Good afternoon, everybody. Thanks for coming in. I'm Nick Collins with ERS. I'm going to give you a quick update on where we're at with the energy assessments. Then I'm going to try not to bore you too much, but I want to talk a little bit about HVAC and like the engineering behind it to help sort of understand why that's such an energy-intensive process in these facilities. And then last, we're going to talk about a study that we completed recently for Efficiency 1 in Nova Scotia on LED lighting and some of the findings that we found relative to LEDs. As you'll see, when we start looking at some of the information out of these assessments, lighting is the dominant energy use in these facilities, and so we would be remiss not to discuss it to some extent. Everything in here is going to be sort of generalized. We don't want to identify anybody's facility or data specifically, so they'll be sort of higher level type things.
Is it against you? And we might actually have you go a little closer to the video camera so
Okay,
you can
sure.
record your voice.
All right, well, I kind of went through that introduction. In case any of you don't know or forgot, I work for a company called ERS. We're a bunch of energy efficiency engineers. We work in energy efficiency, clean tech, renewables, storage, electric vehicles, all that good stuff. We're based in Massachusetts. We're mostly engineers as well as support staff. Me personally, for about 10 years now, I've been working in commercial and industrial energy efficiency. I mean, you name a facility type, and I've probably been in there either implementing energy efficiency projects or evaluating them. That's when we come in after the fact and do measurements on a facility and try to figure out what has the actual impact of these energy efficiency measures been. So that's sort of the perspective that we bring to projects. You know, I'm not trying to sell a product. What I'm trying to do is get the most accurate information that I can. That is my product. For the past 4 years, I've been leading ERS's cannabis efforts with research, implementation, and some evaluation work in Maine, Massachusetts, here in Colorado, as well as in Canada. If those of you familiar with Resource Innovation Institute, I'm on their HVAC Technical Advisory Committee. I'm also on the Facility Design Committee for the National Cannabis Industry Association. So what are these assessments? What exactly are we doing anyway? So we are analyzing your facility energy use. We're using the eGauge data for the electric energy use and where available, fuel bills on the fuel side. We then are doing site visits and collecting information on the type of lighting you have, quantity of lighting, HVAC equipment, destratification fans, all of the loads within your facility, and we build a model. We build models in Excel of each of the facilities, and then we use that utility data to tune the model. So at the end of the day, we have this model in Excel that actually represents the energy use of your facility. That helps us figure out, one, where is the energy going in your facility, to what end uses, and it also gives us a tool to start messing with energy efficiency measures. We now have a model of the facility, so we can play with that and go, well, what happens if we swap out this? What happens if we put in a different rooftop unit? We're also trying to establish energy intensity and productivity metrics. So this might be how many grams per kWh or how many grams per square foot of flowering canopy. And we're trying to establish these benchmarks both for you as individual sites, so you can compare yourself to future performance. Are we doing better? Are we doing worse? And also to give you a sense of where do you fall within the broader grouping of your peers of similar types of facilities. And again, I'll reference Resource Innovation Institute. They have a fairly large database now, probably a little over 200 facilities of energy use data, basic information on lighting, size of the facility, climate zones. And so with that database, you can start to get a sense of how do I compare to similar facilities in terms of my energy intensity and productivity. And then finally, we're trying to identify and then quantify cost-effective energy efficiency opportunities at each of your facilities. And I say cost-effective because we could come out and come up with all kinds of ideas that may improve the efficiency substantially of your facility, but if it takes 30 years to pay back that investment, that's probably not something that you're going to pursue. So we're really trying to focus on those measures that are going to give you the best bang for your buck, the quickest return. Hvac will talk about this here in a little bit, and I'll touch on it as well, but as we're looking at those measures, we're also looking at what incentives or rebates are available through Excel, through PACE, and a credit program that, again, Hvac will talk about. When you factor those numbers in, the payback on a lot of these measures is becoming quite reasonable. So where are we right now? We've completed 13 site visits. We have 4 scheduled this week, maybe 6 if we can get the last 2. That would get us all of the facilities in the county. 7 of our reports are in the final QC review right now. All the reports will be delivered within the next 6 weeks, and we'll be presenting the reports to everybody over a go-to meeting so we can walk you through what is in this report, what are the findings, sort of how did we arrive there. So far, we've found cost-effective opportunities for every facility. The specific opportunities vary. The size of the opportunity varies. While a lot of the facilities are fairly similar in terms of the basic systems, every facility is still very unique, and so the measures that fit well in any given facility are unique as well. Just to give you a broad sense of some of the findings. So this is like an amalgamation of the sites that we've looked at so far. So this isn't anybody's singular energy use breakdown. This is really an average of the facilities that we've looked at. But what I can tell you is that the ranges are not huge. So for any given facility, this is largely what we're finding. Horticultural lighting is accounting for nearly 70% of your total energy use at the 13 facilities we've looked at. Scratch that. That is not the case at the greenhouses. For the indoor facilities, nearly 70% of your total energy use is going to lighting. The biggest next chunk being your HVAC systems, a little bit of supplemental dehumidification in there, destratification fans, and then like your office and plug loads are just so negligible compared to the other loads in the facility. So this is why I got to talk about LED lighting. And I know that there's a lot of reluctance amongst the cultivators to adopt LED, but if we really want to consider reducing energy use, increasing the productivity of the facility, and reducing demand, we got to talk about LED. Some other things that we've found that I can speak broadly to. It's off the screen a little bit, I'm sorry. But the lighting levels that we're finding. So we've been going out with our flux meter and taking measurements at the canopy on all the facilities to get a sense of what are people achieving in terms of PPFD, right? So the photosynthetic photon flux density, which is really just how much useful light is hitting the canopy. That's what matters. It doesn't really matter what's coming out of the fixture. It matters what is the canopy receiving. So that's what we were measuring. Flower, that's the top left. I'm sorry that got cut off. We're finding ranges somewhere between about 600 to the high end of about 1,200. And there's huge variance within any canopy, really. There were a couple of facilities that had really impressive consistency in terms of that PPFD across the canopy. But broadly, there's quite a bit of variance. And why is there so much variance? This little graph gives you a sense. I mean, when you're right under a fixture, you're getting a lot of that output. As you move just a little bit away from the fixture, the amount of light due to the photometrics of the fixture, the way it spreads the light, it really drops, pretty rapidly. So depending on how your lights are spacing and depend on whether or not there's overlap between fixtures, we're seeing 400 over here, 600 over here, 1200 over here. Veg, we're seeing much more consistent values between 400 and 600 ppfd and more consistency. We don't get quite as much variance within even a single area of canopy. Seedlings 300 to 400 and mother 400 to 600. So these three are really quite consistent both in an individual facility as well as across the facilities. The flower rooms is where we're seeing much more variance both within a facility, within a specific room, within a 4x4 canopy even, and again inconsistency, I should say, or variance between facilities as well. One of the things that'll be really interesting in the county level report, so we're doing reports for each individual facility, but we're also doing a report for the county that's going to try to look at all of these facilities and sort of aggregate the information and say, what can we learn from these facilities as a group? One of the things that I'm really curious about, I have no idea if anything will come of this analysis, but do we see any relationship, do we see any correlation between facilities that have higher or lower ppfd in flower and the productivity of those facilities or the energy intensity of those facilities? It's something that I'm personally super curious. The facilities that are running 1200 ppfd, are they getting more grams per flowering square foot? If so, is it because of the lighting? If not, what are those other factors? I could speculate, but I'll wait till the data comes in. I'm going to speculate anyway. I'll tell you what my speculation is. What we're seeing, it's early, but what we're seeing is it appears there's a lot of factors outside of the equipment that dictates how productive a facility is, meaning it's the secret sauce, it's the way the cultivator and the methods that they use, because like I said, a lot of the facilities are incredibly similar, and we see a range of values coming out of them in terms of their intensity and productivity. So that's some of the really interesting stuff, and I think Jacob, when he talks about what he's doing, he may be able to help solve some of those less obviously tangible elements to the productivity of a facility. So what are some of the measures that we are seeing, kind of rising to the top as cost effective? Again, each facility is unique, and so these may not necessarily apply to your facility, and there may be others that are not on this list that do apply to your facility. But these are just some of the things that we're seeing that, broadly are decent fits. LED lighting, we'll talk more about that. We're looking at running opposing flower schedules. So you can either run all your flower rooms at once, which we refer to as concurrent, or you can run opposing flower rooms, half on, half off. There's some real benefits in running opposing flower rooms in terms of reducing your demand. We're also looking at dimming, and that's both for greenhouse operations as well as indoor. Particularly when combined with LED fixtures, you have the opportunity to sort of bring the lights up slowly in the morning, bring them off slowly in the afternoon, maybe even make some adjustments to your full intensity through a full flowering cycle. And there's a surprising amount of savings to be had by sort of a soft start and a soft finish to the lighting. That can be done with HPS fixtures, but LEDs lend themselves to it just a little bit more. Some things that are sort of rising to the top on the HVAC side. Adiabatic Pre Coolers, that's a fancy word. So these are like evaporative pre coolers that go on rooftop units or on the condenser of split systems. Essentially sprays a fine mist of water into the incoming airstream into the condenser. It results in something called wet bulb suppression, and it just makes the HVAC system, it doesn't have to work as hard to reject the heat that it has pulled out of your space. So it reduces the demand on your HVAC system, and it also adds some capacity to your HVAC system. There's great incentives available for this, and it's not a very expensive installation to retrofit. In some cases, we're looking at air source heat pumps. I have an asterisk here. I probably should have put mini split, because really what I'm talking about is mini splits, but with an asterisk. I would almost never recommend mini splits be used in cultivation spaces. They're just in no way designed for the loads within cultivation spaces, and they're difficult to keep clean, so they become a vector for biological contamination. However, there are certain heating systems that would do well if they were replaced with air source heat pumps just for the heating side of things. High efficiency rooftop units, I'll talk a bit more about where does that make sense. It really makes sense more in a new construction or end of life as opposed to retrofit. And then VFDs on fan motors, and so that's both some exhaust type fans as well as supply fans on air handling units. And again, this is just sort of a partial list. There are others, and it's very facility specific. So some other measures that we're looking at but are less promising, and I just wanted to touch on these because I want to give you the understanding that we are looking as broadly as we can across these facilities. We're trying to look at every opportunity, every system, and if there are cost-effective opportunities there. So one that we look at is envelope improvements. This is a tricky one and is very, again, site-specific. The issue with envelope improvements is there's a high capital cost, there's a long payback on them, and it's questionable as to whether or not it's actually beneficial based off of the energy balance of the facility, right? So these facilities are what we call exothermic, meaning they're always rejecting heat, right? The internal loads are so substantial that they're always rejecting heat. So if we improve the envelope, really we're just doing a better job at trapping that heat within the space. So now we're relying 100% on the mechanical equipment to take that heat out of the space. If the envelope maybe isn't quite as good, there's more opportunity for that internal heat to migrate through the envelope and lose some heat through the envelope. Of course, there's a flip side to not having a good performing envelope, which is during the hot weather, you're going to get all of that heat gain in through the exterior conditions. But there is a balance point here, and when we look at the average temperature in Boulder and when we look at the temperatures within the cultivation spaces, we can kind of do that math and figure out where does it make sense to further insulate a building, where does it make sense to really not add more insulation to a space. Something that is beneficial from an envelope standpoint would be what's referred to as high albedo surfaces, so like a white roof. A white roof on a building is going to do a lot to reflect the solar gain and cut down on those loads during the summer. HVAC controls, due to the nature of many of the mechanical systems in your facilities, there's not a lot of opportunity for sort of advanced HVAC controls. The systems operate fairly simply, and so you can't necessarily take advantage of some of the more advanced HVAC controls and strategies. Again, not always the case, but in many situations. A full HVAC retrofit, and retrofit here being bold and italicized. The problem with a retrofit is you have a large capital cost. You're throwing away everything, you're bringing in all new equipment. That's a lot of money. The savings that you're going to get, between whatever it is that you have and this new efficient system, those savings really need to support that entire capital cost of replacing this entire system that is otherwise functioning. HVAC replacements, when we're talking end of life, failed piece of equipment, that's the opportunity to go all in on energy efficiency. So if you have a failed rooftop unit and you need to replace it, that's when you want to get the most efficient rooftop unit you possibly can, because you got to do something, right? You've got to replace that rooftop unit. So you either replace it with a standard unit or you replace it with a high efficiency unit. The efficiency gains you get by buying a high efficiency unit really only needs to support that incremental cost between a standard unit and a high efficiency unit. Because you got to do something. You got a failed unit, you have to replace it. So from an economic standpoint, when you are replacing HVAC equipment, that's when you really want to go all in and get the most efficient system you can. Retrofitting a fully functioning HVAC system is not terribly cost effective. The caveat there is if your HVAC system or any other system is a bottleneck to production, and you can get increased production by replacing these systems, and you work that into the payback calculations, you may have a much more attractive project. But if we're just talking energy savings here, it's really a rare situation where it's going to be cost effective to tear out a fully functioning HVAC system and put in something that is more efficient. And finally, we've been looking at advanced rooftop unit controls. Advanced rooftop units controls is an excellent measure, and it's being implemented all across the country in offices, in medical office buildings, and schools, and the savings are really, really substantial. The problem is two of the mechanisms through which they achieve savings do not align themselves well with indoor cultivation, right? So one of the things that advanced rooftop controls do is they really open up the ability to use outdoor air economizing, to bring in more outdoor air to cool or condition the space. With CO2 enriched atmospheres, that's not really a good fit for these facilities, right? If we start bringing in outdoor air, that means we have to ventilate the space, so now you're blowing all of your CO2 out the window. Another element of advanced rooftop controls that generates savings is called demand control ventilation. So this varies the amount of outdoor air brought into a space based off of the occupancy in that space as measured through carbon dioxide. Again, not really going to work in a room where you've got 1,000 ppm of CO2 and you don't want to bring in any outdoor air. Now there is a version of advanced rooftop controls that they call like Advanced Rooftop Controls Lite, which is basically just speed control on the supply fan of the rooftop unit. There are some opportunities there, but I've yet to find any examples where that has been installed. So we can kind of do some speculative math on that.
We just put ours on.
You just did?
Mhm.
And just a fan speed on supply fans?
Yeah, for the rooftops.
Yep.
Yeah, for the winterizing or whatever.
Nice.
Come check it out.
I definitely will. Because you guys have split system, is that
Mhm.
right? Yeah, I remember
Like
seeing those.
18 of them.
Yeah.
Yeah, can I ask a question, or do you want to hold them till?
I'm happy to take questions. Go ahead. Totally mess up the timeline, but let's do it.
Actually, I have two. One is on the heat pump option. Given that you just said like the indoor grows generally don't have much of the heating requirements, so were you talking about the greenhouses for that?
Indoor grows generally have heating requirements when the lights are off in the flower room, right? Because the plants continue to transpire even when the lights are out, and they create evaporative cooling. So even in the summer, there's usually a need to heat those spaces to some extent to offset that evaporative cooling. And then in the winter, if you're in a lights off period, again, you'll have that much more need. And so there's a couple specific facilities where there's an opportunity to improve upon the way that they are currently heating that facility during lights off periods. And that's an option there. And there are certain size facilities on the small end of the scale where you don't have a lot of options, and mini splits, in fact, might be your best option. But when you see, the back wall of the building just lined with rack after rack after rack of mini splits, there were better options for that facility. So generally, we don't recommend them, but again, when facilities get down to a certain size in terms of being small, it may be one of the better options available.
I have one other question.
Yeah.
The you mentioned high efficiency RTUs, and the idea of if you're doing a retrofit, again, using a high efficiency one. And when you say a high efficiency one, do you mean like including the hot gas reheat kind of system?
Yep.
Okay.
Yep. Or I mean, just even an off-the-shelf rooftop unit with a higher SEER IPLV value, compared to an EER 10, put in something with a 13. But even more so, if you can get in units that have hot gas reheat, you're getting into a more specific sort of unit. And even then, you want to be pretty careful with the units that you're selecting. The range, the environmental condition range that a lot of standard rooftop units, even with hot gas reheat, the range that they can take advantage of that is relatively small. So you really need to look at your room conditions and figure out, can I actually take advantage of this aspect of this sort of stock unit for my particular grow. I mentioned we're looking at, again, energy metrics. So this is, again, it's a range. Not everybody falls exactly in this range, but just to give you a sense of kind of what we're seeing. On the electric side, the electric energy intensity, 200 to 350 kWh per square foot of flowering canopy. That seems to be the metric that the industry is like coalescing around. It is your flowering canopy that produces your sellable product. And so that's going to be sort of that area that we are normalizing energy use to. And then we have our electrical productivity, so how many grams per kWh. And again, it's a range. We're seeing somewhere around maybe between 0.5 and 1.0. That's really interesting. I mean, 1 is twice as much as 5. And so, some facilities are really squeezing a lot more product out of each kWh that they're paying for.
Yeah. Is this for indoor talking about indoor growth?
Yeah, this really does focus on indoor, these numbers here. The greenhouses are different.
Yeah.
They are a different element for sure.
Is that for the whole cycle?
This is annual. So this would be facility annual energy use.
And Nick, what are you typically seeing as far as the utilization of space? So what percentage of total floor area is actual canopy?
Very high. Very high in these facilities. I don't have the numbers off the top of my head, but we have the square footage of the facilities and the square footage of the canopy, so we could tell you that. But these facilities are all plant. You know, it's very high, and the uptime of the facilities is anywhere between the upper 80s to like the mid 90s in terms of annual utilization of the facility. Any more before I start getting into this stuff, which I hope I don't put you to sleep? Any questions on kind of what I just went through, what we're seeing so far, what we're trying to produce? All right, get ready for a quick engineering review. I just feel like, maybe this is just me, but I just feel like if you can understand a little bit more what drives the HVAC process in these facilities, you'll just be that much better prepared to troubleshoot your facility, have conversations with HVAC contractors, and you know, the analogy I like to use is, you know, the best race car drivers, they understand how their cars work. And so I want to just give you a quick overview. So there's two types of heat that we care about. There's sensible heat and there's latent heat. Sensible heat is a change in the temperature of the air. It's the change that you can sense, hence the word sensible, right? So the sources of sensible loads in your facility are the lights, the fans in your air handling unit or your fan coil units, loads coming in from the envelope, circulation fans, to some extent people, if you're using a CO2 burner, which I don't know that anybody is, that can be a source. And if you're using portable dehumidifiers, they introduce a lot of sensible load back into the space, and we'll touch on that here in a minute. So I talked about, you know, envelope not necessarily being a great target measure, and I do mention here though that envelope is a source of sensible loads. Well, let's look at the weather dependence of these facilities. So this term we use is weather dependence and weather independence. So is a facility's energy use dependent on weather, or is a facility's energy use independent of weather? So this is a facility, none of yours, that is running concurrent flower rooms. So they run all their flower rooms at the same time. And so here is a year's worth of data filtered for only the time periods where their lights are on, okay? This along the bottom is the outdoor air temperature in Fahrenheit. The y-axis is purposefully not labeled because I just am trying to hide as much information as possible. But the interpretation here also, you can see this thin black line, that's the trend line of this data. And what I want you to see here is that at 20 degrees, I'm using about that much kW. At 60 degrees, I'm using about that much kW. At 80 degrees, it's about the same. My trend line is super flat. So this is something that we would say, this is weather independent. The amount of energy that this facility is using when the lights are on is completely dominated by the internal loads, and those loads are the lights, exactly. And the equipment that has to process the loads of those lights, right? What about the same facility when the lights are off? Again, there's a lot of scatter of data, but clearly we see something different happening here, right? We see a trend, downward sloping, and so we see that there is some weather dependence here. Depending on the temperature outdoors, my average KW is changing it, sloping downwards. So this is a facility that's actually using more energy in the cold, less energy, somewhere down around here might be the balance point of this facility, and then anywhere beyond here, their AC usage is ramping back up even when the lights are off. So this is the sort of thing that we look at for all of your facilities to help us understand how does this facility operate, and are there opportunities for envelope improvements. So we talked about sensible heat. That one's easy to kind of grasp and understand. You take a lighter and you put it under your arm and you burn yourself. That was some sensible heat right there. Latent heat is a little bit more complex, and this is the type of heat that is really important in cultivation facilities, and it's not necessarily 100% unique to cultivation facilities, but the latent loads experienced in indoor cultivation are unlike the latent loads seen really anywhere else except for maybe indoor pools. All right? So the word latent means hidden. And so this is energy that doesn't result in the change in temperature, but results in a phase change. So changing something from a solid to a liquid, liquid to a gas, and the other way around, gas to a liquid, liquid to a solid. And it takes a ton of energy to change something's phase. The way that I describe it is that you put a pot of water on your stove and you turn it to 7 and that water is boiling. Okay, does anybody know the temperature that water boils at? 212 degrees. I got them boiling. Now my stove goes to 11. I turn it up to 11. It's boiling harder. What is the temperature of that water now? 212, right? So what happened to that additional energy that I applied to the water? Phase change, right? It's going to more rapidly changing that from a liquid to a gas. And this is super important when we think about two things. One is the transpiration of the plant, which we'll get a little bit more to that, but also dehumidification, because both when the plant is transpiring, there's a phase change, and when we dehumidify, there's a phase change. So there's wacky energy at work here. What are the sources of your latent loads? It's really directly related to the irrigation rates, the amount of moisture, the amount of bulk liquid water that you're putting into your veg, your flower rooms. That is the primary source. Okay, if you have a CO2 burner, you can get a tiny bit of additional moisture introduced. It's hardly worth mentioning. And then depending on your methods, if you have open water storage, you can get evaporation off of that water as well. And so all of this combines to form this thing called evapotranspiration, which is just evaporation and transpiration. Evaporation happens off of your grow media, water on the floor, open water containers, whatever. And transpiration is the plant's process of gas exchange, right? So cannabis being a dicot, it has stomata on the top and bottom of the leaf, and it's breathing. What happens is that water that is in the plant is a liquid, and when it transpires, it comes out as a gas. That means that we have a phase change happening, right? So whenever the plant is breathing and transpiring, it's actively cooling the space. And that is a super important concept that just a couple years ago, we just saw so many HVAC designs that did not understand this and did not take this into account. And the plants don't generate a little bit of cooling, they generate a ton of cooling. So they really offset the sensible loads in the space, but at the same time, they dump a ton of moisture into the space, right? So yeah, they're cooling, but they're also dumping in a bunch of moisture, and that creates a very unusual environment that, you know, industry is not accustomed to having to deal with. You all know all of this, but again, the plant, the stomata open, the CO2 goes in, and water and oxygen comes out. The majority of the transpiration does happen when the lights are on, but it does not stop when the lights are off, and we have some graphs from some data that we collected that we can show that. And just to give you a sense, I talk about evaporative cooling being like substantial in terms of how much it can cool the space. This is an actual facility in Massachusetts, a 1,900 square foot flower room. They had 500 plants. They were generating 8 tons of cooling, just the transpiration of the plants. This room had, I think, something on the order of 20 tons of total cooling load. 8 of those tons were being provided just by the transpiration of the plants. But now, again, we've raised that humidity because we're dumping all that moisture into the space. And that creates really weird, what we refer to as a sensible heat ratio. A room like this was designed for probably a sensible heat ratio of 0.8, meaning most of what has to happen in this room is we got to cool it off, not a lot of dehumidification. We see flower rooms with sensible heat ratios as low as 0.4, meaning there's very little cooling that has to take place in that room, but there's a ton of moisture that needs to be removed. That's a problem because the mechanical systems that serve these types of spaces are meant to serve sensible heat ratios of 0.7, 0.8, 0.9. They're not designed to serve sensible heat ratios of 0.4, 0.5. So when you take typical commercial HVAC equipment and you put it in indoor cultivation facilities, you've got a real mismatch between the equipment's ability and the loads of the space. So what does that transpiration look like? Again, this is real meter data from a facility that we worked on. This is a 1,300 square foot flower room. This is the average across 1 month towards the tail end of the flower cycle. So you can see here, this is gallons per hour on the left, time of day on the bottom. So they start off about 10 gallons an hour, 12, 14, 16, peaking just around 14, and then what do you think's happening right around here? Exactly, the lights go off, and we can see that the transpiration drops rapidly, but it doesn't stop, it doesn't go away. We're still removing 8 gallons an hour from this space. So what does that look like a little bit more over a full flower cycle? This is the same facility, and again, this is just the tail end of a flower cycle. 1,300 square foot room, and you can see again, this is now gallons per day, up over 250 gallons per day that we're pulling out of the air of this space. And then, as you can see, once harvest begins, just an absolute precipitous drop-off in the amount of transpiration that's taking place, the amount of condensate that's being removed. That's kind of obvious, like, yeah, you took the plants out, of course, but I just want to drive home the point that the plants are the dominant force in these facilities. Their need for light and the need to remove the moisture that they exhale, those are the dominant forces here. All right, so I know I'm moving fast. I just want to try to get through everything. I usually talk too much and don't. Any questions on sort of HVAC type stuff before we talk about lighting? All right, so this spring, my colleague Jesse Remillard and I think some of you probably met Jesse when he was out in June and August doing some of the assessments. We worked with Efficiency One in Nova Scotia. They were doing an evaluation of their industrial program, and the evaluators came to them and said, we've got a couple cannabis facilities in the sample here, and we don't know how to address these. We don't know what to do with these. And so they wanted us to basically come up with a study for them to use in their evaluation as what should be the baseline lighting for reviewing those projects. Through the course of doing this research, we were really looking a lot at LED fixtures as well, and we felt like we were starting to make some connections and lights were coming on in our minds going, oh, I think I maybe see what's going on here in terms of why have LEDs got a pretty bad name in the industry so far. So I want to just take you through, what we found, and it's food for thought, right? Because I'm not a grower. I understand that there's a lot of concerns about converting to LED, but as an energy engineer, I also recognize that that is a huge opportunity to reduce the energy use in these facilities. And the more that we've studied this, the more that I'm coming to the opinion of, I think the latest generation LEDs are there, and I'm going to explain to you why that is. Just real quick, so we have some sort of common language. Horticultural lighting in the terms that are used are totally different from space lighting. They're sort of analogous, but they're different. What we really care about is PPF, photosynthetic photon flux. This is the output of a fixture. Doesn't necessarily mean that that's what hits the plants, it's just what the fixture puts out. Then we have the PPFD, the photosynthetic photon flux density. This is what's actually hitting the canopy. This is what really matters in terms of what the plant cares about. The plant doesn't care what the lamp's doing. The plant cares about what it is receiving. Then there's the photosynthetic photon flux efficacy, the PPE, and this is really a way of rating how efficient can a horticultural light fixture produce photons in the PAR range, the range of light that the plants care about, which is generally this range, between 400 and 700 nanometers. There is a lot of discussion about the plants do like some ultraviolet, they do like some infrared. Again, that's sort of above my level of knowledge, but largely accepted within academia is that PAR, the photosynthetic active radiation, is between 400 and 700 nanometers. So how do we measure that light? Well, there's some weird terms that you're going to hear, and I just want to give you a quick sense of what they are. People talk about micromole. What the hell is a micromole? Micromole is 1/1,000,000th of a mole. Well, what is a mole? A mole is a quantity, and it's a quantity equal to Avogadro's number. This 6.022 times 10 to the 23. A big number, right? So we use micromole just so we can have a number that we can actually digest and say with our mouths, like 1,000 micromoles, 600 micromole. And what that is it's actually expressing the number of photons, the actual quantity of photons that are being emitted in that par range. So those are just some key terms. So let's talk briefly about spectrum. So here's the spectrum of daylight. You can see lots of blues, you can see some reds, you can see infrared, you can see ultraviolet. And this is something called the McCree action spectrum. So these are the various compounds in the plant associated with photosynthesis. And these are the wavelengths that these compounds really respond to. And so this is a really interesting piece of information when you really want to get down into the nitty-gritty of the plant's sort of physiology in terms of, you know, what elements associated with photosynthesis care about what. And if we crudely overlay that, because I don't know how to Photoshop, that McCree action spectrum over the daylight spectrum, and this is where I say crude, you know, like I've roughly lined up 700, 600, 500. You can see, boy, doesn't that fit daylight incredibly well. Again, not shocking that plants respond to natural daylight, right? Well, what do the spectrums look like of some various lighting technologies out there? So here's a T5 fluorescent. Not much going on in the blues, not much going on in the reds. There's some green, there's some orange. Doesn't look a whole lot like daylight. Metal halide, okay, we got more blues. We still got a nice spike in the yellow. Still doesn't look much like daylight. High pressure sodium, we all know and love. Very little blue, lots of orange, red, and even some, you know, far out beyond the 700 mark. Moving along further, we got ceramic metal halide. Okay, we've got a lot of that orange and red that we had with high pressure sodium. We're also adding a little bit of the blues and some of the greens and yellows as well. And then finally, you've got what's achievable with LED, which is essentially a replication of the daylight spectrum. You know, you go back a few years and a lot of the LED manufacturers were selling lights that were very purple in terms of the color. A lot of people refer to them as blurples. And they were really focusing on the blues and the reds. The majority of the top tier manufacturers nowadays are offering, you know, full spectrum or broad spectrum lights that look a lot more like this. So where am I going with this? Well, what's the impact of spectrum, right? There's all this talk about spectrum. I know that a lot of LED manufacturers really promote the fact that they have tunable spectrums, either that you can tune it yourself or that they have a range of products with any number of spectrum. Here's the thing, and again, I'm not a cultivator, but I read a lot. All of the academic studies out there, and this is just one from Bruce Bugbee, and if you really feel like getting into this kind of stuff, look up Bruce Bugbee and read his papers. This one was published in PLOS One. And the big takeaway here is that there is considerable misunderstanding over the effect of light quality referring to spectrum, on plant growth. Over the past 30 years, numerous long-term studies with whole plants have shown that it is light quantity that matters much more than light quality spectrum. So what the plants want is PPFD. They want micromole. The more micromole, within reason, the better. Spectrum is less of a concern for photosynthesis than putting photons to the canopy. Now, spectrum definitely has an impact. I don't want to say that it doesn't. I see a lot of non-peer-reviewed studies of LED case studies are not peer-reviewed, so take it for what it's worth. But demonstrating that they switch to LEDs and that their terpene profiles are way stronger. So there's definitely some impact for spectrum, but from my position, from the studying that we have done, what you want to do is achieve high PPFD at the canopy. And if you know what you're achieving now under high pressure sodium or ceramic discharge, if you achieve that same level with LED and you're doing it in a broad spectrum, it's really hard to understand from a scientific point of view why the plants wouldn't respond the same to those high levels of photon delivery within a broad spectrum. Now there's some caveats there that I'll touch on here in a second. So what is the deal with LED? There's this perception that LED can't produce the quality and yield that HPS can. Historically, LED lights had lower efficacy and lower output than 1,000 watt DP HPS. The most recent LED fixtures meet or exceed the output of double-ended HPS fixtures. So now this is where I'm going to speculate for a little bit. But one of the things that we kind of realized as doing this study for Efficiency Nova Scotia was the LED vendors were marketing these LED fixtures as one-for-one replacements for double-ended 1,000 watt HPS. And so that's what people were doing. They were buying these fixtures and putting them in one-for-one for HPS, and the plants didn't like it at all, and they said these things are garbage, and they threw them out. And when you look at what we kind of refer to as the first generation LED fixtures, that makes sense. They didn't have the output. And if you did replace your 1,000 watts one-for-one, you like cut the amount of PPFD to the canopy like in half. And if it's light quantity that the plants really care about, no wonder you had poor results. You know, you just put a shade over that plant essentially. And so we believe that you really need to focus, if you're considering LED, on ensuring that you're achieving an equivalent PPFD to what you're currently doing, if not even higher. Couple things on just sort of form factor of LED fixtures. This one on the left, this is a fluence fixture. This is really becoming the form factor du jour. The spotlight type fixtures are really going out of style, and they're producing these much larger, that, you know, each one of these is a bar of LEDs. And this promotes much more even light distribution on the canopy. Where you don't want to use a fixture like that is in a greenhouse, because it's going to provide a lot of shading. So for greenhouse applications, you know, the top vendors make these single bar LEDs to try to cut down on the shading that they can inadvertently put on the canopy. Another thing to consider for the greenhouse operators here is the weight of these fixtures. Some of them can weigh upwards of 60, 65 pounds. I worked on a project in Maine at a 60-plus acre tomato farm, where they were like in the final design to put in, it was actually fluence fixtures, and they realized, hang on a second, it was like a traditional sort of Venlo style greenhouse. They realized we can't hang these thousands of 65-pound lights from the structure. It won't support it. They would have to have built a whole new superstructure within the space to hang the lights from, and that just absolutely crushed the economics of the project. So something to keep in mind. All right, this graph is not super intuitive, so I'm going to just try to point out the good stuff. So what we're looking at here are HID, so 1,000 watt HPS really. What we refer to as second generation LEDs, these are sort of the latest and greatest, and then the first generation LEDs, which, you know, are not so great. And so what we are going to try to compare here is the amount of power required to achieve a certain output from the lamp, right? So if we look again at these blue squares, second generation, let's say we're 600 watts power, we can get, you know, 1,500 ppf out of the fixture. That's pretty good. Well, what about if we're trying to get 1,500 ppf out of my high pressure sodium? That's this trend line here. So I just kind of follow this across, drop it down. I need almost 800 watts to achieve the same output of the fixture. So what this demonstrates is that the LED fixtures, the newest generation, are becoming much more efficient in terms of their ability to produce PAR for less input power. You can kind of make that same comparison to the first generation stuff, which is real lumpy and ugly. But similarly, like if we're trying to achieve 1,300 to 1,500, we follow this trend line up, gosh, almost to somewhere around here. And again, you're looking at nearly 800 watts necessary to achieve that level of output from the fixture. So again, big takeaway here, LEDs are improving at a staggering rate. Signlight's consortium, which I'll talk about here in a minute, the minimum PPE that they require to be listed is 1.9, and now there's a number of fixtures on the market that are at 2.6, and we're hearing of fixtures that are even higher, 2.9 and even 3.0 I heard about from the DLC rep last week. So it's just really rapidly improving. Another chart that's a little difficult to follow, but I'll just walk you through it. Again, we've got our little diamonds, our HPS. This sort of teal is our best-in-class LEDs, if you will. and the blue squares are the earlier generation of LEDs. So let's say we're trying to achieve a certain ppfd at the canopy. Well, what is going to be my lighting power density? How many watts per square foot of canopy would I need to achieve that? If I'm looking at second generation and I'm trying to get 1,000 micromole at the canopy, so that's somewhere around maybe 40 watts per square foot. What about if I'm using my HIDs and I want to get 1,000? Man, I'm way up here. I'm somewhere around 65 watts per square foot. So again, the big takeaway is with the newest generation of LEDs, you can achieve the ppfd values that you want for lower lighting power density. So it's getting there.
Is this
Yes.
taking into account like universal distribution? So like apples to apples, like you could have one HPS light equivalent to 2 LED lights like in the same space and canopy optimum height and all that?
Good question. So this is all based off of the manufacturer's recommended mounting height and spacing. And so that's, do they recommend the best? I don't know. But that's, in order to try to like normalize this as best we could, we said, all right, this LED vendor says mount it this high above the canopy and it gives you this coverage. Hvac says mount it at this height and it gives you this coverage. So we use the manufacturer's recommended mounting heights and coverage patterns to come up with these values here.
So you see how that makes sense, it's watt per square foot, it doesn't necessarily correlate to how many units you would need.
Correct. Yep. Yep. We can then work into what is the number of units, and I'll actually get to that at the end. That's sort of the final is what does it really take if I'm going to replace 1,000 watt HPS with LED? Can I do it one for one or not?
Nick, how are the prices? Are the prices coming down for the LED fixtures? Is it still like 4 or 5 times the cost of?
Yeah, they're $1,200 to $1,400, and that's something that I've been really surprised over the past, say, 3 years. Those costs really have not changed, Brad.
So, but the capital cost is what portion of the cost of light?
Say again?
That capital cost is what portion of the cost of light?
The capital cost is what portion of the cost of light?
That standard cost of light equation that factors in energy use over the useful light, decommissioning, etc.
I have not done that math.
I mean, that's really the math you do to say whether that additional capital cost is worth it.
Correct. I mean, we are doing payback calculations.
Same thing.
So
Yeah.
I don't know that we have those there, but what I can tell you is without incentives, without rebates, without credits, it's not very attractive. You add in the credits and the rebates and the incentives that are available through PACE, Excel, and the offset fund that Zach will talk about. And in my opinion, we're looking at a very valid and a very achievable conversion to LED. Without that funding, it's a very difficult thing to sell because of the expense of the fixtures. And I do have a slide on expense that we'll hit on real quick.
Are there resources to help us do that?
Do what?
To get the rebates and stuff?
Yes, absolutely. PACE.
We tried, and Excel told us no.
Okay.
They were at that for a while, but since then, I would say in the last, what do you think, Jay, year and a half, they've
Yeah.
I can make a pretty good
Maybe
argument
cases
for
a little
energy
bit more.
productivity on the last PACE application I did,
Mhm.
and they got pushed up to some supervisors and
Yeah.
slipped through, so.
And we had a call with Excel,
ours
what,
also.
a month ago?
Mhm.
About a month ago, we had a call with Excel and just said, we're doing this effort right now in the county. There's gonna be a bunch of stuff coming your way. Can you give us a special liaison almost? What is the process for, horticultural lighting? What about custom HVAC? So we've tried to start greasing the skids. PACE is definitely a resource to help you get through that, and ERSs as well.
Yeah, they wouldn't even talk to us about HVAC.
Yeah, see,
They
that's,
said we have full, brand new, custom everything, and they told us basically to kick rocks.
yeah, we can help with that.
HVAC is a little different too than the lighting.
Yeah, well, we have
Depends on
LECs, and that's completely different than all this stuff. and
Yes.
It's extremely efficient. They wouldn't even hear it.
Yeah, that's unfortunate, and that's
I got a
something.
rebate on CMHs.
You did?
Yeah, I'd argue energy productivity over efficiency. That's
How long did it take?
about 12 weeks-ish.
Yeah.
Yeah.
Yeah, it was like a month ago.
Yeah. I'd say with Excel, you have to talk to the right person. There's like 3 people that are like tasked with making sure that rebates get into the cannabis industry. Everyone else is just, you know, whatever they'll send you to like their head calling office in Milwaukee, and you're gonna get nowhere.
And we can call you guys, and you guys can help us with those people.
Yeah, I can put you in touch with the ERS is doing it. I work a lot. I went to Cannabis Conservancy, so a little different company.
Okay.
But with Cultivator energy optimization, that's what they kind of specialize in, especially with Excel, because they're so difficult to work with.
Yeah, they are.
Yeah.
I mean,
Kinda
we,
mean.
you know, I've been implementing the efficiency main program for over 10 years, so I talk the language. I know how to beat down Excel and tell them the right things.
Cool.
So I'm happy to help as well.
Call
And
me.
I would add, Excel has learned a lot in the past few years. When they
Yes.
started their custom lighting rebate program for growers, targeting growers, they were trying to use an energy productivity metric, and they didn't know how to do it.
Mhm.
They scrapped that. They came back with a photon efficiency metric.
Mhm.
So they're casting about, and I know people over in their new products group that are analyzing the industry. Excel still doesn't know exactly strategically what they want to do with your industry, and they're conflicted because they go to in front of the Public Utilities Commission with all this. You know, on one side they like the added load.
Mm-hmm.
On the other side, they need to be incentivized to do what's best overall for everybody in the system. So they're figuring all that out. So I wholly agree with what Jacob said. You need to talk to the right people at Excel, and you need to have a good advocate. And we'll get to that a little bit later in the presentation with the base people.
Yeah, and I mean, whoever, I don't remember the person's name, whoever we spoke to, I felt like was very open to custom applications for HVAC. You know, they were quite familiar with at least their current approach to looking at horticultural lighting. So clearly there are people at Excel that are working more specifically, you know, within the cannabis industry. And again,
that might have been Adam White.
do you
Yeah.
remember?
Um,
Or do you remember?
It wasn't
it wasn't
there.
Denise,
There's,
it wasn't
key account-
Jean.
I'm sorry.
I don't think it was Jean that we spoke
No,
with.
it was, they have a key account rep working with John Snyder, who's also their
John's
custom
been
person, so
there for a little
together,
while. Mhm.
they're kind of taking this on, and I
Yeah.
think we will see some expanded
Yeah, but between,
offerings through Excel's custom program.
great,
I think the outcome of that call was really good, so.
that felt
I'm
like, you know,
optimistic that we could put something in front of them.
but between PACE and ERS, we'll help, you know, navigate that.
Yeah, I would summarize all that by saying any frustrations that you had with Excel are probably still going to be there, but it's very different now than it was even 6 months ago, probably.
Yeah.
Cool.
Yeah. And any custom incentive program is a little bit challenging to navigate, even under the best conditions. But
Thank you, guys.
We can definitely help that happen. So where does this all kind of wrap up? Some LED guidance. LED manufacturers' self-reported data, and that's kind of an important caveat, self-reported, shows that very few can actually replace double-ended HPS 1-for-1. There are some out there that, based off of their published data, can do it. There's not many. The performance of LED fixtures really varies dramatically between manufacturer and even the generation or the age of the LED fixture. All LED fixtures are not created the same. You really want to look for the highest PPE value you can, as well as a high PPF value. So if you're looking at a fixture with a PPE of 2.6 and it's got a PPF of 1700, that's a strong LED fixture, and that definitely has the capability to replace double-ended HPS 1-for-1. So all in, end of the day, when and this is a blend, you know, we blended a bunch of first generation LEDs and their performance. We blended a bunch of sort of the latest and greatest, so there are some in here that aren't as good as others. What we basically found was if you're trying to replace 1000-watt double-ended, if you're using the old sort of questionable first generation LEDs, you could need as much as 40% more fixtures to get equivalent PPFD. The second generation stuff, the good stuff, anywhere between 10% more or no more, an actual 1-for-1. They both still produce savings, believe it or not. It's just not necessarily the level of savings that the vendor or the manufacturer is going to claim. So that's sort of my big warning almost to you, is if you're considering an LED conversion, there's homework to be done. All fixtures are not created equal, and you really want to focus on PPF and the PPE, and you should have a target PPFD, right? What's actually hitting the canopy. That should be part of sort of your design criteria. You know, I want 800, I want 1200. that way you can design a system to actually achieve that stuff. And definitely, if you don't have a light meter, it's like the best light meter on the market's about $500. It's not a huge investment, and that'll give you the ability to not only validate what am I doing right now, but if you start to swap out LEDs or do a test section of LEDs, put them up, you can measure it and go, oh crap, it's only 600 ppfd. We're looking for 1,000. And so before you go all in, you can do a little bit of testing and see what am I getting here. Again, there's a number of groups that are actually working really hard to try to make sense of the horticultural lighting world. You've got ASABE, the American Society for Agricultural and Biological Engineers, IES, the the Illuminating Engineers Society, and then DLC, Design Lights Consortium. So DLC does now have a horticultural qualified products list. These are the basic requirements: 5-year warranty, a efficacy of greater than 1.9, and like I'm saying, you want to be aiming for like 2.6, but this is sort of the bottom. Spectrum distribution, so they're showing you how much is within certain bands of nanometers, and then distribution. The problem right now with the qualified partner list is that it's fairly new. It only came out October of last year, and there's a lot of the best fixtures aren't on that list yet. So we're kind of recommending to various jurisdictions that until that list gets more heavily populated, allow the manufacturer to give you a warranty and to produce some test results to show that it meets these things, and then maybe that's good enough until that list gets built out further. Again, my concern with this industry in a lot of ways is putting the cart before the horse, actually moving faster than our understanding of the industry goes. And so a lot of jurisdictions adopting that QPL list and saying, I'll only give you an incentive if it's on that list. That's a concern because we know that some of the best fixtures out there aren't on that list, and so it doesn't make a lot of sense. So advantages, they're more efficient. There's reduced heat gain into the space. You've got more options for spectrum and dimming. They are expensive. I'll show you that on my next slide. They are heavy, and in some cases, less sensible heat gain. You're going to pay a little penalty for that in terms of more heat needing to be put into the space. We've yet to... maybe we did find one. I think we've yet to find any facility where even if there was additional heating necessary, on the whole net, there were still savings to be had there. So yes, there may be a small heating penalty, but it does not offset the rest of the savings. And just costs, we talked about costs. To give you a sense, the blue dots are LED costs based off of the wattage of the fixture, and the black dots are your HID or HPS fixtures. Not surprisingly, 1,000 watt is sort of a common, and so we've got a lot of grouping around that. And these are almost all under $500. So you can go out and get, a Gavita double-ended 1,000 watt HPS with electronic ballast for under $500. An equivalent, in theory, to 1,000 watt would be like a 600-something watt LED. And those costs are up here, around $1,200. So there is a massive gap still between the cost of really what I consider to be the standard practice double-ended HPS and what we're trying to push people towards, hopefully, which are the most efficient LEDs. And Brad, to your point, absolutely, without incentives, rebates, and the like, the paybacks are really challenging because of that really high cost. That's $1,200 to $1,400, and that's just the fixture itself. Never mind the labor associated with hanging those fixtures. So I don't know how I did on time. I went as fast as I could. I'm not good on time. Just my personal final request is we're trying to wrap this up here as quickly as we can. For those that have given us production data, thank you. We're going to be reaching out to everybody in the next week or so that where we did not get production information. And if you could let us know as quickly as possible, it would be really beneficial. It's a really important metric both for you as an individual site and for the county as a whole to try to figure out, where are the opportunities here. All of that information stays, confidential within your report, but it is a real important element for this overall assessment and evaluation. So that's it. Yes?
Can we get a copy of
Sure.
the presentation?
Fine with
Yeah,
me.
if you email me, I'll make sure to get it out to
And
you.
then I had a second question. When you're looking at costs analysis and payback.
Mhm.
Is our added cost of being in the impact fund included in that analysis or not?
Do you want to talk about, is that something you would cover, Zach, in your credit component, or I don't want to get that wrong?
Just because when we're evaluating the cost, because that's an additional cost we would have that's not based on.
The question she's asking is, are you adding the offset fee into the rates when you calculate payback?
For your reports.
Yeah, you did.
Adding the offset fee.
So I mean, if you have the XL rate, then you
The
add
2.26.
2.16.
Oh, yes,
per
yes,
watt hour.
yes,
Yeah.
yes.
Okay.
Yep, that is included, yep. Anything else? All right, well, thank you very much.
And if you also have, other questions you think of, Nick will, I don't know if you have a slide with your email on it, but you can feel free, or
I'll
you
put a
can
pile of
reach out
cards.
to me and
Yeah, I'll put a pile of
we
cards
can get
up
those
here.
questions answered for you too.
I'm here all week.
And so Zach, I'll have you come up. Do you want me to pull up the letter that we sent out? So we just sent out the EIOF credit explanation in the last invoices that went out to the cultivators. So you should have a copy there. It is also included on the Boulder County website too, a copy of this, of what we're putting up. And then if anybody needs, an additional one, you can always request it from me. And then just a couple of housekeeping items too. All the plates and napkins and silverware are compostable. There's a little green bin over there and a recycle bin for the cans. I don't know if you want me to pull up now.
I'm gonna grab another one on the way out. Appreciate it.
Yeah.
And bathrooms are down the hall and around the corner.
All right, so I'm Zach with Boulder County with our Partners for Clean Environment program. I work with Ambra. Just off the top, who is familiar with this credit program? Who's heard of it at all? Okay, a little bit, okay. Who understands it? Excellent, cool. We're gonna hopefully fix that. So the intent behind the credit program is laid out here at the top, and I won't read it, but I'll just walk through it. Basically, we don't want the energy impact offset fund fees to prevent your ability to invest in energy efficiency, right? That's kind of counterproductive, right? It doesn't make sense. So we've put together this credit program where if you make a eligible energy efficiency upgrade, a portion of the cost of that upgrade will defray your future credit fees. Yes.
So all of our stuff is brand new.
Mhm.
We did it kind of to these guidelines,
Mm-hmm.
and we just got our whatever bill.
Mm-hmm.
Where do I go?
So unfortunately, this is just for
Crap.
retrofits. Yeah. I recognize that that's a. I see the challenge there.
I already spent
this
a
is-
bunch on getting efficient stuff.
Right. This is from the time that the program was implemented going forward.
Okay.
And we can talk more about it.
Okay,
offline.
cool.
Yeah,
So when was
yeah.
the program implemented?
It was announced a couple weeks back, I think. Amber, when did we send out the announcements about the
2
credit
weeks
for-
ago.
2 weeks ago.
In the invoices, yes.
So how this works, it is not to exceed 100% of the project costs when combined with the other rebates available. So that's Excel, that's the rebates from PACE, and any other provider. And I think this is an important point that you have now 3 sources of incentives for energy efficiency upgrades. What you can get from Excel from their prescriptive or custom programs, the rebates from PACE, which were already able to be combined with the Excel rebates, and now this credit. There's a $2,000 or $20,000 cap on the credit per project, and the credit is good for the lifetime of the business until the credit has been used up. If there is a remaining credit, should it come to pass that you're, making the decision to close down, and there's a remaining credit, that cannot be redeemed or transferred. It's just specific to your business while you're in operation. Any questions on that? Yes.
Is that $20,000 cap from the EIOF fund or combined rebate?
The cap is for the EIOF fund credit. Yeah.
What if you sell your license in the building and someone else is just taking over, like a new operator? Will that credit transfer?
No. Eligible measures are any projects which are rebated by PACE or Excel, as well as any of the identified upgrades that are identified in the ERS reports. Even if PACE or Excel doesn't have a rebate for them, we will work with you on those. So here's the process. You identify an upgrade you like to do. You're going to contact Ambra and work with her to identify what eligible rebates are available. She'll help you with both PACE and Excel. Then we have just a simple form we're going to have you fill out. It's one page. It's very easy to calculate the amount of the credit. It's basically what's your project cost minus what are the Excel rebates, minus what are the PACE rebates, and then we'll add the credit there on top. We will authorize a provisional credit at that point, and it's important that, like with PACE rebates, it's the same thing for the rebates as it is for the credit. Work should not begin until you've received written confirmation that the rebate and the credit are being held for you. And this is, gets to the situation where we don't want to have expectations of, well, I'm going to make this upgrade, and I'm going to get this credit without having that confirmed and validated. So it's just to make sure that everybody has mutual understanding. Then you'll complete the work, and then you'll submit final paperwork, final invoice, documentation to PACE for both the PACE rebates and the credit. And then we will keep that credit on file and track that for you as future EIOF invoices come in. Any questions on that?
Just had one comment. Do you want to talk about how the PACE rebates work as far as timeline for how long we have?
In terms of?
Of just like better in the beginning of the year.
Yes, thank you. Yeah.
And then also just, I guess, like pre-approval for most of Excel's.
Yep. Yeah, thanks, Ambra. So PACE's rebates are renewed on an annual a calendar cycle. So January 1st, we have a fresh pot of money. If you come to us in late December, it is possible we will be out of funds. Our rebates are first come, first serve, and we don't have always in all years enough, to serve, all the projects interested in the year. So earlier in the year is a better time to come ask us. Even if we're out of PACE rebates, the credit is still available, and that, is not, that's basically money that you're not paying, and so there's no real, aside from the $20,000 cap here, there's no limitation on that. It doesn't matter the timing of the year for the credit. And then to Amber's other question on Excel, if you're doing a custom project, you do want to have that pre-approved. There are, for like T8 office lighting or some other projects, there's the prescriptive rebates where you can do the project and then you have up to a year to apply for the rebate. But for the most part, for any horticultural lighting or HVAC custom projects, you need to have pre-approval. So it's a little work that's required up ahead of time. So here's an example of how the credit works. So let's say we've got 49 existing 1,000-watt metal halide fixtures, and we're upgrading to ceramic metal halide. Here's the total project cost. Here's the rebate you'd get from Excel. This is the PACE rebate. So this is the situation that existed before the credit program. Now here you're going to see the credit kick in. So this is your project cost before the credit. This is your project cost after the credit, which brings it down to a pretty reasonable payback period. If we're looking at the energy savings, we're looking at both the savings on your Excel bill, of course, but then also your avoided EIOF fees. So here's the estimated KWH savings, the change in your annual energy cost. Here's what you were paying in your EIOF bill. Here's what that's being reduced by through your efficiency upgrade. There's your new EIOF bill. But then with that $10,000 and change credit applied, instead of paying $13,000 in your next coming up EIOF bill, you're paying $2, effectively $3. Then once that credit is used up, then you're back to your regular calculation without the credit. Any questions on that? Or anything about the credit? No? Okay. Any thoughts, comments, questions in general on the structure?
I guess I have a question.
Yeah.
What's going on with the monies that have already been accumulated into the EIOF, since this is a credit-based system, not?
Right, so this doesn't impact that. And the committee's working on, what happens with the funds that have been collected. Having Nick out here today and doing the assessments, that's one use. We are still working through, where the funds from that have been collected will be applied. We don't have that answer yet. But
How much money
stay
is
tuned.
there?
That is a good question. And you would think one that we would have our finger on. What has happened is the county has upgraded to a new financial system countywide, and it has been not as smooth of a rollout as would be expected. We will get you that answer. I am still waiting on that answer. I asked a month ago, and I don't have that answer yet. We will, as soon as I know, we'll share it out with everybody. Yeah. Mm-hmm. Yes. Yeah. It is a reasonable question, no doubt. I know before Brad left, he was saying around 200,000, I think.
But I don't know if that included.
That was prior to ERS.
Right, prior to ERS, and is now more than 6 months to a year old. So spent some money, collected some money. I don't know right where we're at, but it gives you a sense of what's there. Yeah.
It's probably still around.
Yeah.
That's awesome.
Yeah. Great. Well, if you have any other questions, you've got Amber's contact information, and we should follow up and just talk that through.
Yeah, that'd be cool. Thank you.
Mm-hmm.
Appreciate your help.
Yeah. Great.
Right. So next up we have. Next up, I will get Jacob set up here. I might need to plug in. Dave, did you want to check the power on your phone? Just to make sure we have enough.
It should be.
Okay.
Still going. I didn't think you could do video for an hour and change. So talk to my friends at Cultivator and Optimization, so they can help you out, especially for HVAC. It's something they've been working on.
Cool.
But Excel still hasn't done what they said they were going to do, is to actually create a program to be able to do like on the spot rebates. But they said they're saying 2 weeks, 2 to 3 weeks for lighting. It's just like
To get it started?
to get the approval.
Oh, really?
Yeah,
Okay,
2 to 3
cool.
weeks lighting. Depending on the HVAC, can be 4 to 6 weeks, just depending.
All right, well, thank
what's
you so
with it.
much.
Yeah,
All
no
right.
worries.
I think this one might be working now.
Yeah.
Going back and forth,
Yeah, rebates are necessary.
Yeah.
I think the battery might be dead in this guy's cell.
Oh, no worries. Okay.
Just watch the cables.
Sounds good. See some familiar faces in here. Super nice. So I'm Jacob Politzer with the Cannabis Conservancy. I guess a little bit, or what we're going to talk about today is Boulder County Carbon Conscious certification. So the EIOF funds, some of that's being used to offer the certification to you guys for free for the next 2 years. And the idea behind that is to give you guys a market-driven, market-based tool to really have recognition in the marketplace to your consumers for all the work that you guys are doing, and for all of these fees that you're paying, and for essentially the audits. And so I'm the co-founder and now director of science certification for the Cannabis Conservancy. We have 3 certifications in the marketplace. I'm also the board chair for Sun and Earth Certified, which is a regenerative beyond organic certification, mainly in California. So we've been doing certifications for the last 5 years in the cannabis space, with over 25 years experience doing international sustainability certifications. I would say I'm a grower by trade, now a gardener, since I'm doing all of this. But really what we are focusing on with the suite of certifications we have, and now adding this one, is really to align the cannabis industry with international norms and protocols of a certification to be same aligned with fair trade, organics, etc. Since none of them will really deal with the cannabis industry, but really trying to show tangible impacts. For these, it's environmental impacts. For Boulder Carbon Conscious, it's energy reduction, energy efficiency, ultimately carbon reduction. And so, the goal of this, the moonshot of this, is to get carbon neutral cannabis cultivation. So reducing energy consumption, increasing carbon offsets. From grower perspective, it's really just reducing energy use and increasing yields, and showing that trend, measuring in that, monitoring what that is, and then relaying that back to consumers. And that's really where the job of us facilitating the certification is coming from. And fortunately, with the great work that Nick and Jesse have done at ERS, all of the auditing aspects of it has already been done. We're going to be taking that report and essentially categorizing that with the standards that we develop. So a lot of the heavy lifting has really been taken off of you guys. To go over, if you guys just to kind of review, benefits of a certification system, why certification schemes matter. They are voluntary. It's really to go beyond regulation, or in the cannabis industry, a lot of times to ward off a lot of regulation. Boulder County is really, interested in taking an industry-leading stance on reducing energy consumption of cultivation facilities, but the state is also interested in that. Governor Polis is really looking at achieving Colorado's 2040 climate change goals, and the cannabis industry is always known as a huge energy consumer. Whether or not that's actually true compared to other industries, it's kind of the label that's been given to our industry. But from a cultivation levels, really what we're trying to do is reduce your energy usage, which is going to be a lot of the guidance that's coming from these EIOF audit reports. And so the idea, one of the ideas behind doing the certification, is to give you guys another incentive to actually read the certification and start to implement some of the guidance in there, by giving you, a reward at the end, and having a verification process. And so that's what we're doing as a certification, is, taking these audits to actually have you guys measure and monitor what it is, and then getting some more information from you guys, because we realize that while you can have the metrics, what we've seen from an actual implementing and an actual tangible reduction in energy comes from upper management down. So we're going to look at, policies and things like that, which I'll go through in a little bit. But, benefits. So you have the, reason implement, compliance support. To achieve certification of this, we will be creating a grower manual that's going to take you step by step by step. So you're going to feel confident, you're going to feel comfortable being able to achieve certification on your own without taking too much of your time. I know your time is valuable, and that's something that we've been working the last 5 years on, is how to have a very high bar, integrity driven certification without relying so much on taking up all of your valuable time. Some of the other benefits is that consumer and public awareness, on a state and national level. This, I do feel strongly, is going to put Boulder, Colorado, you guys, on the map. It's going to be the first energy carbon conscious, carbon reduction driven certification internationally, especially specifically for the cannabis industry. And you guys are setting that baseline. You guys are leading that trend. I am talking with some people in the state government that are really interested in doing some kind of system like this in the next couple of years and are looking at this as potentially a model for that. So you guys could be leading the trend for the entire state, the entire country, the entire industry. But for you guys specifically, why get a certification? Why get a seal of approval? So you're gonna be able to put it on your products and be able to show that to the consumer. So I know, Boulder County has a lot of vertically integrated grows. So one is, keeping up with the Joneses on some level, a co-opetition, as we like to say in the industry. You guys are kind of competing against each other, but you all are trying to achieve the same goals. And so you have that aspect of it, but also it's consumer facing. So there's a huge opportunity to do a marketing campaign around this to really bring in, a new set of clientele if you're already there, or to expand your clientele. Look at like the different niches that are available. What we're seeing nationwide, is you're having more of the baby boomers who are looking to get product. The soccer moms, things like this. Like people who do care and do have the extra money to be able to spend money with their values, and this is providing them that educational piece, that understanding for it. So it does open up a lot of new consumers. If you are white labeling or you are selling it statewide, premium price potential is definitely there. What we're seeing in California with our other certifications is being able to sell for an 11% premium and actually sell 30% faster. That's more for our top line, our eco, and our sun and earth, but the potential is there. And that's in California where everything is going crazy, but we can't keep our products on the shelves in California. And that's, it's selling for $41 an eighth, which is, 11% more than, that kind of premium thing there. And that's from this past 6 months. But then also the consumer loyalty. I mean, we all look at brands, we look at New Belgium, different Colorado brands that have that kind of customer loyalties because they, have that, educational piece to it, that recognition there that they are putting, these things in place, and it's not just greenwashing. The whole idea behind this is to avoid the greenwashing, and the biggest benefit is that it's free for 2 years. So granted, it's not necessarily free because you guys did pay into the fund, but we're using some of these funds to offer you for no additional cost. And so we've worked out with Boulder County to offer this for the next 2 years for free, and then the idea is that the success of this program, the Cannabis Conservancy doing our job successfully and marketing this, is that it will, have a financial, a cost to it that you guys will be willing to pay because there is, value there. So how we've kind of designed this, and it's still a bit in motion because we are working on designing it now, is 3 years of having annually increasing stringency. So to get you guys all comfortable with the certification scheme, get you into the mindset of record keeping, because record keeping documentation is kind of the basis of any kind of certification. Normally we would audit you guys annually, but it's one audit to essentially determine and predict what you guys were doing for the last 365. Nick of the ERS has done that audit for us. But to continue to make sure that these things are going to be implemented and you guys are going to continue on this path, record keeping is going to be a big component of this, and we have some solutions for that I'll show later. So that's essentially the big thing is to measure, monitor, understand what your metrics are, these productivity metrics that Nick just outlined. Sorry, I'm going to trip on this. Have some policies in place, and a lot of the heavy lifting was done, and so the idea is that you guys are going to understand what consumption, what energy usage you're using, where it's being used, and you'll take that information and start to use that in your decision making. And that's pretty much all we're asking for you guys for the first year. The next year, we're going to require, it's going to be a little bit more stringent, but we're going to require like internal energy policies, so things that have worked successfully in the past before, like employee trainings, how you guys are using your automation, your climate control, things like that. Have these things been thought out and done? As well as goal setting. So actually having like a tangible reduction. And that's going to vary, I think, between all of your grows because you realize those are all different, but we're going to be basing it off of these reports. So we'll see with these recommendations that Nick was discussing, and we'll discuss with each of you kind of what that is. And as we get these reports, we're going to be able to fine tune what this is. And then idea of by year 3, we'll have quantifiable, reductions. We'll be able to say that, you saved 10%. you save 15%, or your, most likely your energy productivity metrics, so how much energy you're using and how much yield you're getting is going to increase. And all that is, essentially by you guys doing that, you are saving money right there. I mean, that is reducing your overhead. You're growing more with less. And then idea here is also start incorporating some offsets as well to really like focus on, it's not just energy, it's carbon. And
Just a quick question
Yeah.
on that reductions. I think I heard you, just want to make sure I'm hearing it right. So
Mhm.
we don't care what's happening at the electric meter. We care about the efficiency with which they're producing. Is that right?
well, that's what I'm most interested in
Same
is,
here.
yeah. But also reducing. I mean, the idea is to get to this like net zero. That is the end goal. So we do have to lower, the energy use. But I think be able to compare apples to apples, to be able to compare, 2021 to 2020 is through that efficiency.
Yeah.
And that's what we want to see is that trend towards, getting the most out of, the least.
Yeah.
Realizing that, we're all, a lot of people are in older buildings, no one is really, doing these ground up designs. Everyone's kind of dealing with their own handicaps, so it's really getting to that best place and then improving it, and then telling the consumer, we're in Boulder County, we're growing it the most energy conscious that we can, in the world, and prove us otherwise. So how the certification process is going to work is you're going to apply. We're going to do an in-person meeting. So it's very similar to this, where we're going to go through the entire certification, all of the standards, give out all the handbooks, walk you through the whole process, what we're expecting. And that's going to, I'll go through the timeline next. But essentially you guys are going to apply to this, agree that you guys are going to abide by these things. Originally that was also going to include having you guys sign the energy audit report permission. But since it's going through the county and I have to sign NDAs with the county, we're all signing NDAs together, so I'll have access to that information. And if you do, you have the option of opting out to that. I do take all of your information extremely serious. We work with grows all over the country, and that is a massive thing, is to make sure that nothing ever gets out of our system. And everything that we would ever release through this would all be anonymized, amalgamized, so it'd be, ideally all 17 grows, kind of what Nick was showing today, so that no one grow could ever be, figured out unless you guys wanted to. But that's the idea behind that. Then you do the audit self-assessment. So normally this would be where a third-party auditor would come in. Nick has already done that. So the audit report for this year has already been done. Next year we're talking about having PACE auditors come in, but I think everything's kind of being figured out. And then self-assessment is to the standards that aren't included in these audit reports, which is more policy aspects. You guys would make sure that you are doing compliance and then showing us proof of that. And then we would review the whole package, so the audit report and what you guys provide. If there's information that's missing, which is mainly what this desk audit style is going to be doing, then we'd send you out a corrective action report. This is what's missing. We'd wait to get that back. A lot of the things that we do corrective action reports, because we look at like energy, water, and waste, things like that is more on the water and waste and having testing and things like that. Then you get the certification, the logo use agreement, and all of the marketing collateral. So pretty simple, easy to do process. So this is the time frame as it stands today. The logo is being designed and will be ideally targeted for that done is January 1st. The logo design is going to reflect Boulder County and the surrounding, in this area. We'll have the standards done for this around January 15th. We're going to open up like the application by the end of January is our target date. We're going to have this information meeting with all of you guys sometime in February, where we'll all sit down in a room. We'll go through this entire thing. Probably be a 2-hour meeting. We'll provide lunch, very similar to today, so everyone can feel comfortable with what this scheme is going to be. And then the idea is to have awards, certifications awarded to everyone, or be on a rolling basis by around March, and we'll probably as things are progressing, do some kind of campaign around it, get some press involved, all of that, so that there's really big big deal about this because I think it's you know, a really huge, unique opportunity that Boulder County, you know, is embarking on, and you guys specifically. So the scope of the standards. So a lot of this is what we've done. Is these are already our standards for our energy efficiency aspect of our eco certification, and then we've just started to adapt them to be Boulder County specific. And so we look at policy and implementation, and so that's what we're going to be kind of requiring from you guys. A lot of the bulk of this stuff is going to be in year 2, but for this year, we do want to, you know, see that you guys have an energy policy. That energy is being considered in your decision making. And then I believe in year 2, we're going to look at energy use, like your SOPs, how are the systems run, you know, training. One thing that we've seen in the last 5 years is the biggest indicator for energy efficiency or resource efficiency is like employee turnover, you know, and then it just comes down to training. You know, do people know how to use these systems? You know, a lot of the time the head grower has left and then everyone's just struggling how to use this system that, you know, they really developed the secret sauce for. And so, you know, what we're trying to see is that, you know, you have this equipment in place and that you're using it appropriately. Then energy metrics, which is a big thing, which is what Nick is going to be providing with you guys. And then we just want to see that you guys are keeping up with, you know, doing that on a monthly basis, ideally, so we can see seasonality. Infrastructure, I believe Nick is covering as well in his report. You know, annual energy audits has just been done. Most of this stuff is all going to be included in your report, but this is kind of showing the scope of it so that we can, you know, confidently say that we are, you know, carbon conscious, we are energy, you know, efficiency. We are looking at all of the different ways that energy is being used in the system in ways that we can, you know, feasibly and financially and appropriately reduce it. So as it stands now, here are kind of the year 1 requirements. So from you guys, what we want to see is a company energy policy, and we'll provide templates and sample language and things like that if you don't have it during that first meeting. You know, enough to you guys feel confident writing it, but not enough where you can just cut and paste it. So like that, you know, happy medium. And then a record keeping system plan. So how are you going to continue to monitor your energy productivity metrics? I'll go into one system next that is a free tool if you guys choose to use it, but you're free to choose any system that makes sense for you guys. You know, on a very simple level, we can provide you a template on how to take your metric data, how to take your utility bills, and do these calculations, or there's some automated aspects as well. You guys all have the e-gauge meters, so it's really just taking the e-gauge data, tied to your metric data, you know, and making that align. And then a facilities maintenance plan, and that will be provided to you by the ERS guys, if I'm correct on kind of the sample report that you had sent me, like kind of that template. You guys are gonna provide some facility maintenance guidance, and so I saw that. Originally I was thinking that would be kind of a year 2 thing, but since you are being provided with ways of maintaining the equipment, which has been shown to really reduce your energy consumption over time because the equipment is running, you know, as efficiently as possible. I think we're going to include it in year 1 of actually taking what Nick will be telling you and having some kind of facility maintenance plan. Then from the audit report, we're going to be able to glean your energy use breakdown, so what your lighting, HVAC, climate control system spans, your building envelope, all of that information we're going to get from the report, as well as your current energy efficiency measures, and then energy reduction guidance. And so energy reduction guidance is really going to help us figure out what's the right incremental stringent step for year 2. Because we're not trying to set the goalposts too far, but we're trying to show that, you know, there's progressive improvement with this certification amongst all the cultivators, and so we'll be able to see what these are and say, okay, this makes sense, you know, this is the common denominator, you know, that we were going to require for everyone. And then if you guys go above and beyond, great. And there's an option of us even, you know, tiering the certification if we're seeing that grows are, you know, really achieving like almost, you know, a net zero or 75% towards there, and there's some goes here to really, you know, facilitate that and kind of encourage more, you know, growers to get there. But for right now, we're just going to deal with the simple certification. So one way of tracking your data, I've been on the development team of this for the last year and change, is we're calling the blooming benchmark. It's similar to RII's energy score, except this is going to be real. What am I trying to say? Real world. It'll be uploaded daily, so that it's just my 20-minute warning. The Colorado Department of Public Health and Environment created a benchmark similar to this for the small craft brewers alliance that got the ownership of that now is with the Brewers Association, and they have over 400 brewers using this, looking at their energy, water, and waste, to be able to compare apples to apples across brewers across the entire country. So we were brought in to help advise on how to do this for the cannabis industry. We've partnered with Cannabis Big Data, which is a local Boulder company. So they're the ones who are going to be facilitating the servers, because they have experience with keeping all the servers' data, all the servers, private data, private, etc. The way this does work is that we don't actually own any of your data. You own the data. We just host it in this system. So that, one, the state doesn't own it, so it's not open to Kwh, so no one can have access to your data. But also, we feel that it's your data. We're just providing a service to help give you usable information with that, to like crunch those numbers. And then everything is done anonymously. So right now we have the bar set that we're not going to release any information like geographically or greenhouse-wise unless there's a minimum of 10 grows in there, so that the data can't be, oh, I know what that grow is, I know what that grow is. So for, Boulder, ideally, if you guys all use this, then we'll be able to put it up. And the only people who have access to this data are other growers who've submitted their data. So we have 3 sections: energy, water, and waste. If you only do energy, which is all we're requiring you to do, to achieve compliance with this as one way, you would only be able to see energy data. If you wanted to add in your water, you wanted to add your waste, you'd be able to see all of the grows around, Colorado. We just finished beta testing with this a couple weeks ago, so it's live now, but it'll be live in the final version. We're just now working on how we want to do the reports to be able to give it to you. To be similar to, probably a lot less detailed actually than what Nick has done. But the idea is to be able to have enough grows in here to be able to track it real time. You guys be able to see like how are you doing per month, per day, compared to all of the grows that we get there. And it's really shown a significant reduction in resources for the craft brewing industry. So we're hoping it'll have the same effects for the cannabis industry, and this is all completely free. We've all donated our time, and the Colorado department, Caitlin Urso, who's leading that endeavor, is, it's part of her job, which is awesome. And then for how to reach compliance with this is our grower manual for our sustainability certification. We're going to be creating a very similar one for this, which is going to lead you, it's got step-by-step through it. This is, at this point, it's almost 100 pages. But that's because we have 200 standards for our sustainability certification. This one's going to be far less. But what the idea behind this is that we want you to feel comfortable that you're going to be able to achieve compliance and you understand what you're getting into. And then each year we're going to be doing the same in-person stakeholder, meeting about the certification before the certification launches. So as it gets stricter, you guys are all, feeling comfortable with that and have say and understand what's going on with it. And so this is going to have templates. So if you wanted to do record keeping by hand and have those on record, you'd be able to do it there. Policy guidelines. If you need SOP guidance, we have an SOP template in there on how to fill it out and what's been helpful that we've learned from. We certify right now around 65 growers for the Cannabis Conservancy certification and 39 growers with the Sun and Earth. So with these 100 grows that we've been, working with, things that we've been, been able to help with, like how this, works for you guys in the most efficient, useful way. So kind of how reaching compliance for next year will look, attend the in-person certification meeting. You'll learn the standards. You'll receive the compliance guide. You actually don't need to sign that audit permission form. Now they learn that we're coming in this massive NDA with everyone. Submit the relevant documentation, which for the first year is going to be policies and plans. So energy policies for the company, and right now it looks like just facilities maintenance plans. And then you become certified, and we'll give you a logo use agreement, which will have all the logos you'll be able to use for print, media, and packaging. And then one thing we'll be working on is like initial marketing collateral, so you guys understand how to talk about this, what to talk. Because one thing we do want to avoid is making claims that aren't true. You know, like we're net zero right now. You know, for instance, but to be able to give you guys everything you need to really do a push, and ideally this is going to, you know, put Boulder County on the map and make people want to come to Boulder to buy their cannabis, you know, from all over Colorado, but all over the country as well. You know, and then also have people mimic, you know, what we're doing here, but also I think that this, you know, by going through this process, by seeing what ERS has done and everything that you guys are doing here, you know, makes you guys all pretty, you know, valuable as consultants, and just, you know, getting that knowledge out there that you guys are actually, you know, putting energy efficiency, you know, as a priority in how you're cultivating, and not just, you know, trying to grow the highest THC percentage cannabis out there. So, yeah, thank you guys. And feel free to call me, email me with anything you need. And I will be keeping you guys all updated through probably Ambra as we progress, especially when we get our standards out. I'll have this sent around so we can get some, you know, feedback from you guys. You know, I don't want to create anything that's not useful and not applicable and not attainable. You know. Thanks, sir. Any questions? How do you guys all feel about it? Am I forcing something on you guys don't really care about? Are you guys excited about having a certification put on your product?
How close can the indoor grow get to net zero?
Not super close, but the idea is that you're aiming for it, you know? Shoot for the moon, be amongst the stars. You know, greenhouses, just because they're not using much light, you know, if any light, are a lot closer to that. You know, as Nick was saying, it's 70% potentially. However, I think that with buying carbon neutral, so we have some indoor grows in California that are close to net zero because they get all of theirs through PG&E net zero hydro facility, and they buy additional carbons to offset it. So, you know, technically they're carbon neutral. Since there's not a source, readily available sources I know of in Colorado of clean energy, is Brad gonna?
Actually, we have been promoting Renewable Connect on the program.
So through Renewable Connect.
Renewable Connect is recognized as a valid offset, and there's not much of a cost premium for that. So we promoted that in the past in this program. We got not as much uptake as I would have thought. We even did the calculations for you. There's more capacity that may be coming online this coming year. We'll promote it again, so hopefully people will pay a little bit more attention this time around and take advantage of that, because that gets you out of the fees. And the county sees that as carbon neutral energy.
And so I said that's like kind of like where year 3 will start to come in, is to have to do a carbon connect or something like that.
There's separate certifications for indoor, outdoor, greenhouse, one certification.
For this carbon conscious, there's going to be one certification. So essentially, it's recognition that you guys are participating in this program, that you guys have been audited, that you guys are using this information in your decision making and are striving towards, you know, carbon reduction. That's the idea behind this. I think as this certification progresses, so this year for our, like for instance, for our sustainability certification, this year we hit a critical point where we kind of had our outdoor grower revolt, as I like to say, and so we had to create, now we have our, you know, simply eco, which is only for outdoor or greenhouses that are growing in the ground, and then simply efficient, which is indoor or greenhouses that are usually growing on foundation. And there's some leeway with the greenhouses, but because it does need to be, you know, I think the recognition needs to be there, and we did have growers like outdoor greenhouses, you know, indoor, do you feel like, you know, you can't be sustainable if you're indoor, that kind of thing. But I think to get this off the ground, to get consumer understanding of it, consumer acceptance of this, you know, and educating them on one certification is easier. And I think as it progresses, especially when we start adding intangible targets, is when I think we might split it. You know, the option is there to split it to do indoor, greenhouse, or something like that. But for now, just to get it out there and get people to understand it, and the idea is to get consumers demanding it, because you guys in this room, all 17, 19, grows are the only ones producing this. So if it's going statewide and people are demanding this and they want it, and you have a set supply, so demand's going to go up. Ideally, you'll get a cost premium from that. Or price premium, not cost premium, but yeah.
I'm on the steering committee and I'm excited to buy my first carbon conscious product in late March or early April.
Yeah.
Any last minute questions?
I just have, since we're new, we have no baseline, can we start this? Or can we be compared to the old facility? Because we'll do everything that, so.
Well, right now, this is not, we're not trying to compare you to what you were. This is a blank slate. So,
Well, we don't even have a report.
but you will get a report?
We don't even have our report yet.
Oh, okay.
Like, we took over a space, we
Mm-hmm.
renovated, we focused on manufacturing first, we're building indoor and
Right.
greenhouse, we did an outdoor grow, full on outdoor. With no power, other than security lighting.
Mm-hmm.
So are
30
you,
amps.
are you Renaissance?
Growing, formerly the growing kitchen,
Oh, okay, so you're Wilco.
yes.
Okay.
So we're definitely interested in participating however we can, but we're meeting tomorrow.
Yes.
To look at, we're designing a new facility, so, we don't have a report.
Are you currently growing now?
We did an outdoor harvest, but we're not growing right now.
Okay, but it's Boulder County grown to be sold this year, but you guys just harvested.
Yes.
Okay, I mean, I could work with you guys, and we could do something retroactively if you've got documentation. I mean, we're talking energy, so energy is super easy. So I'm doing like a massive 6
We
8.
ran off 30 amps.
Yeah. So you got utility bills, so I'm more than happy to work with you guys to get you into this program, for sure. I mean, I don't want to exclude anyone just because you weren't quite there yet. So we can devise something to figure out and get you there for sure.
I want to talk about something.
Or maybe also,
Yeah.
when you get up and running, then they could
Yeah.
start from there, and just, I think the idea is to develop your baseline whenever you start having data, and then try to, I think the idea is wherever you are, try to show some improvement, show that you're striving towards, some improvement in your energy use.
50 or something like that.
Yeah. So yeah, I'd say like the whole idea behind this is, year one is to figure out what you're using, know what your baseline is. You can't change if you don't know where you're starting from. Year two is to show that you're using this information in your decision making to, improve something. But we're all figuring this out and what that improvement looks like. So
And I would say, even if you have state-of-the-art facilities as the equipment, you commission that as you start using it, and then as Nick said, a lot of we're talking about energy productivity, not energy efficiency. If you can get twice the production out of the same facility using the same amount of power, you drop your energy intensity of the product, your productivity is doubled. And I don't think there's a grow in this portfolio that can't make substantial improvements with the equipment you have. And there are resources, many resources in this room to help you get there. That's what we're trying to get across, and that's what Jacob is going to say. Are you making an earnest effort to do so? So certainly the certification is wholly up to you. And those of you that are just finishing your facilities, you feel as though you have sunk costs that cannot be changed. That does not mean we cannot help you. And we are going to discuss the problem that you were describing. So unfortunately, the program had to first learn about your facilities before we can come back and channel that money back into them. But your peers are sitting on the committee to help do that.
And I have some ideas, Joe, about how we might address your situation to set you up for improvements, and noticing those improvements. And we'll talk about that.
sharing it
Great.
to
Well,
do
with
it
that,
is
if there's
like
any other
one
questions,
thing
feel
that
free
I wanna
to
be working
email
with
myself, Nick,
He's
or
in
Jacob,
shoes.
and then thank you all for coming today, thank you for your time.
Like, there's a couple facilities that are using like the same equipment,
Feel free to take
the same
photos.
style, but they're using completely different productivity metrics. So some are like 0.5 kilowatts, some are
It's like 20 minutes.
whatever they need, and it's like and it's like, well, what are they growing for? How are they reporting it? You know, is one like, oh, everything's dried flower? Is one actually doing dried flower, meat buds, you know, shake, trim? And are they going for oil? Are they doing that? But then also, like, how big are their pods? What's your growing media? So that's what I do, is trying to get them those set up plans, and then working with, like, breeders to, like, figure out, you know, so I think, like, all of this is great, but we're still working against nature. So shouldn't we be breeding plants that grow best under cities or grow best or whatever? You know?
Going to that point, that's where I'm at right now, is trying to, I actually see, I look at grants to concentrate stuff like that.
Yeah.
So whereas my colleague, an indicator of energy performance, when I look at that product, and I see that, I can look at the same flower rate, but
Yeah.
double the extract, it looks great. If it's reporting every picture, it's kind of efficiency and productivity metrics.
Yeah.
And it's what Quality Transform standard on reporting
For that.
for that specifically, and having to be kind of that presented in a way that is easy to process, because I base my metrics on wet bias.
Yeah.
Because I can turn my products.
Yeah.
Super stratification that areas are like
But when I start converting that into dry, it's not necessarily wearing out
Exactly.
without a footnote on exactly what it's doing.
Yeah. Yeah.
I can take my wet bias but it's like,
Right. And like, yeah, and like what, like I would want to see from you guys is like obviously what you have to put in metrics like the wet, but then if you're doing fresh frozen or you're going straight through that, then like I'm more interested in what you're talking about is like grams of like THC, CBD terpenes, whatever that may be to what you've done, because that's what's useful to you and that's what matters. Because does it matter if we help you grow 20% more biomass if we're actually like potentially just growing more water and less what you actually need, you know, whatever it is, or, you know, and like looking at it from that perspective, which like for you, I would say like I'm from a medical